Okay, so today we're going to talk about how to determine solubility using a chart. So you actually have this chart, it's not green, but you do have this chart linked on Canvas under course resources, and I'm going to show you how to use it today. So I have some examples. These are not on your assignment, but you have plenty of space on the back or on a blank sheet of paper to write them down. So I'm going to walk you through kind of what aqueous and insoluble mean, and then we're going to be writing symbols in each of those blanks, and that's exactly what your assignment looks like. So aqueous means soluble in water. So let's start there with a definition. Aqueous means that it was dissolved and it's soluble in water. And the symbol we're going to use is AQ for aqueous, all right? And then insoluble obviously means not soluble in water, so not able to be dissolved. And that symbol is an S. And I know that sounds kind of backward because you're thinking like, well, if that one means soluble, why don't we use an S? Because the S here kind of stands for solid. So think about it that way. If it's an S that you're writing, it means that you made a solid or a precipitate, okay? So insoluble is S and soluble is gonna be AQ. All right, so that's what we're gonna be using symbol-wise on this assignment. The little blanks are pretty small, so you're either writing AQ or S. Remember, AQ means soluble, S means insoluble. So let's look here at our chart so you can kind of see how we're gonna read it. So you have your ions here. I want you to notice that almost all of them are negative. So we're gonna be looking at the negative part of each of these compounds. Same thing here. And then we're gonna see the solubility and then if there are any exceptions. And I'm gonna show you how that changes the solubility. So let's look at this first one. It says NH4Cl. So we're gonna look at the negative part, which is the second thing listed, so that's Cl. So we're gonna find Cl on our list, all right? And Cl is right here, all right? And it says it's soluble, okay? But it says there are some exceptions here. So if it said soluble and there were no exceptions, we would just write AQ and move on with our life, okay? But this is one of the ones that does have an exception, so we're not gonna write anything yet until we figure out what our exceptions are. So it's gonna be soluble, so it would be AQ, unless it's with AG, HG, or PB. Specifically, HG2+ and PB2+. All right, so those are the things that we gotta look for. So our very first thing listed, we have chlorine, and it's with NH4. Well, NH4 is not on this exceptions list, which means it's not an exception, and it's gonna stay soluble. And the symbol for soluble is AQ for aqueous, okay? Let's look at the next one. So we have RbClO3. We're gonna look at the second thing, the negative. ClO3 is what we're trying to find on our list. Found it right here. It's called a chlorate. It says it's soluble and there are no exceptions. So I don't have to think about it. I just know it's gonna be AQ. It's soluble no matter what it's with. All right, let's look at this one. We have NiF3. So we're gonna look at the second thing again. So that's gonna be the F and it's down here. All right, and it is insoluble, which is why on your thing on Canvas, this is colored yellow. On my green, it just looks gray. But this is insoluble in general, and then there are some exceptions. So this is talking about from the periodic table. So group 1 is that first group on the periodic table. So let me show you what I mean. So this is group 1 on the periodic table. Anybody in this group is gonna be an exception for that. If F, in this case, if F is with anybody in this group here, that would make it now soluble, okay? But it's not. Ni is not in this group, okay? So it's not one of those. The other choice is that if the F is with NH4+. So we need to see if it's with NH4. It is not. So what that means is it's going to be insoluble. And again, the symbol for insoluble is solid or S. So that means it would stay a solid in water. All right, let's look at the next one. We're gonna look at the negative, the OH part. So we need to find OH on our list. Let's go through all of them. So that's down here, that's hydroxides. They are insoluble for the most part, except with these. So except if it's with group 1. So let's check and see. We have Ca. So Ca is what it's with. Ca is not in group 1, so it's not that exception. The other choice, we're looking at hydroxides, is Ca+2 is my compound with Ca. It is. That means it's an exception. So instead of staying insoluble, it's going to become soluble, which means it's going to be AQ. It does dissolve in water. Okay, next, the anion or the negative part is SO4 that we're going to look at. So that's right here. It's soluble except with this long list of things. So let's see if we can figure out if ours is on the list. So this is sulfate. It's going to be soluble except when it's with calcium. Ours is not with calcium. Barium. Ours is not with barium. SR. Ours is with SR, which means it is an exception, and that makes it insoluble. So when something is an exception, it's going to be the opposite of whatever this chart says here. If it's on the exceptions list, that means it's no longer whatever this says. It's the opposite of that. If this says insoluble and it's an exception, that means now it's soluble. If this says soluble and it's an exception, like this example here, now it's insoluble or solid. So I'm going to write S for insoluble or solid. Okay, next is BR. So see if we can find BR on our list. That is right here. These are the halogens. It's soluble, and there are some exceptions. So we need to make sure and see what our compound is with. So we already looked at the BR part to figure out that it's soluble for the most part, except when it's with AG, HG, or PB. And ours is with HG, but I want you to pay attention to something. This says HG plus 2. Okay, so we need to figure out what charge it's using here. All right, so this is where the periodic table is going to come in handy. So BR's charge is -1. All right, so let me grab a different color so you can see this. So BR's charge is -1. All right, so remember they have to be opposite but equal in opposite charge but equal in number. So if this is -1, that means HG is using +1 because when I crisscross, it's 1 and 1 and the 1's disappeared. So HG is actually using +1. Well, HG plus 1 is not an exception on this list, so that is not an exception. It's also not with PB. So that means this is going to stay soluble, which we're going to write AQ. So you do have to look a little bit closely on some of those exceptions with the charges. All right, our last example here is PbI4. So that's a halogen here, soluble, except with these. Okay, so let's look at our list. So this is our I, it's soluble, except when it's with AG. Ours is not with AG. HG, it's not with HG. And it is with PB, but we got to check and see our charge. So this says PB plus 2. So we need to figure out what charge PB is using in this compound. All right, so I has a charge of -1 from the periodic table. All right, and if I were to crisscross these, this would be a 1, and then that means that PB here is using +4, right? If I were to uncrisscross these, if this went that way and this went that way, the 4 would belong to the PB and the 1 would belong to the I. Same thing here, this would be a 1 and this would be a 1, okay? So this is PB plus 4. Is PB plus 4 on this exceptions list? It is not. So that means it's going to stay soluble and it's going to be AQ. Remember, AQ means aqueous or soluble in water, okay? So that's how you're gonna do that on your assignment. You're just gonna be writing in the blank either A, Q, or S. And you're gonna do the same thing for the other ones, just there's gonna be 4 for each of the equations. Remember, you can always email me if you have any questions or if you need help reading the chart.